So we'll start the program by clicking the desktop icon, Microchip Studio. This is the welcome window of Microchip Studio. Go to the File menu. File, click New, File, then click New. On the right side, you'll see some option, okay? You'll select the project. There are several options, C, C++, Assembler, Microchip Studio Solution. You will select Assembler. It will display AVR Assembler project. Select AVR Assembler project, give a project name. LED. So I have given a name, LED on off blink. After giving the name, you can select the location. If you click the browse button, then you can give the location where it will save all the relevant files. Now select OK. So when you select OK, it will give a window to select your device. So our device is ATmega 328p microcontroller. So on the search box, it is easiest way, okay? Fastest way, search box give some part of the name. Let's say 328. So it will display the relevant hardware. We'll select 300 ATmega 328p. Now on the right side, it will give the device information of the hardware. Okay, so click OK. Now it is creating the project. So it has created a file called main.asm. This is the assembly language program file. Over here, you can write your program. I have saved the program in a text file. So let me copy the program from there, okay, directly to save the time. So this is the program. Look at the program. The first line dot include AM328p definition.inc. This is a library file we have added that has all the relevant documentation information relevant to ATmega 328p microcontroller. Some part of the program may refer to this document. If you write a bigger program, then this document will be required, okay, for some definition. So this is the file we have included for this program. This is the code segment .csv. Under the code segment, you write a program code. This is a .org. 0 means in the AVR microcontroller memory at the location 0, this program will be loaded. Okay. The first line LDI R7, 0B 00000001. Our job, look at the diagram. Yes, I'll explain. This is our Arduino Uno. Our job, what we are going to do? We are going to connect a LED at pin number 8 over here. At pin number 8, we are going to connect a LED and we will turn on and off the LED, then we will bring the LED. Okay. So this pin number 8 belongs to port B pin number 0, first pin of port B. Okay. If we look at the documentation of Arduino Uno data sheet, look at over here. The port B register has the address 0x25 hex address. In our assembly program, we'll use this address to load 1 or 0 at bit position 0 to turn on and off the LED. Before we turn on and off the LED, we need to make this bit as an output pin, right? So how to do it? By using the port B data direction register. Port B data direction register has the address 0x24. So we'll send this the data direction register 8 bit. If you want to make a particular pin output pin, we write 1 over there. If you want to make a particular pin input pin, we write a 0 over there. In this case, this pin 0 for port B will be the output pin. So we'll send a high value 1 over here at the address 0x24. Okay. After that, we will send a high value at this bit position 0 to turn on the LED. To turn off the LED, we'll send a low value at the bit position 0 at port B, and this is the hex address 25. Okay, so let's go to the program. So what we have done, we have saved the value x value, okay, 0x01. That means binary value 0000. That means all the bits, bit position 1 to 7, they are the input bit, input pin we have defined. Only the bit position 0, we have defined this is the output pin. Okay, so this value we first load in the register, general purpose register 17. Then from, okay, I think let me copy the code directly from there. Let's copy the code. Okay, look at over here. We send this binary value to general purpose register 17. Okay, we have given a 1 at bit position 0, so that bit position 0 of port B will be the output pin. Okay, so we load this value by the command sts in the location 0x24. That's the location of DDR-B register. Okay, so after this command, the pin at bit position 0 of port B will be the output pin. Okay, after that, we load the value 1 in the register port B. Okay, and this address of port B register 0x25, and we load the binary value 00000001. This one will make any device that is connected at bit position 0 of port B on, because we have given a 1 over here. 1 will be representing the high value 5 volt. If you give 0, it will be the 0 volt. So by this command, we are sending a 5 volt at bit position 0 of port B. So if you connect a LED over there, that will be on. If we give a 0 over here, the LED will be off. Okay, so let's test this program. This is a loop. This is the for loop. It is just keep on looping. Okay. So go to your program. Save the program first. File. Save it. Save the SPLMS program. Then go to the build menu. Okay. From the top menu bar, choose build and choose build solution. Build solution. If everything is successful, go to the tool menu. The tool menu, as you see, we have defined a tool called Uno. Okay, by using the command external tool. If you click external tool, then you can define your own tool to work with a particular hardware. We want to work with the hardware Arduino Uno, so we have given the location in the command line of the Averdut program. That's the compiler that will compile your program, external compiler. And you need to give the complete path from your Arduino Uno installation location. You will get the complete path of the Averdut program and give the location with the file name over here. Okay, that's the command for the compiler to be used with to compile your program. Then on the argument, you need to supply this argument. This argument you can find from this online documentation how to flash a program from your microchip studio. Okay, look at over here. In this argument, there are two things are very important. The name of your hardware. This will be different for different hardware. For the Arduino Uno, it is ATmega 328P. Second thing that is important is the port. When you connect the device to the computer, it gets connected to the port. If you choose the device manager, look at over here, go to the search option. Choose device manager. If you look at the device manager, there's an option called ports. If you just click the port option, you can see at what port your device get connected. Okay. In this case, it's COM port 7. So that's important for us. So over here, we need to give PCOM 7. Okay. Give PCOM 7. And other things you can leave as it is. So you can copy this portion, go to your program, external tool, and copy that portion in the argument section. Okay. Again, on the argument, two things are important: the name of the hardware and the port. Okay. Then click use output window, click OK. Now that tool will be displayed on the under tool section. We have given the name Uno. Click Uno. It will program the device. And as you see, the LED is on. Okay. The LED is on. Now we will make the LED off. Okay. So how to make the LED off? We'll send a 0 at port B. Okay. Give a 0 over there. Save your program. Reveal the solution. Go to the tools menu. Upload it by selecting your tool that you have defined. Select Uno. That the LED is on. Now I will change the program so that the LED will blink, keep on blinking. Okay. I have written the program in a separate text file. Let me copy the program from there. So I have just copied the program to blink the LED. Okay. File, save your program, then choose the build menu, rebuild solution. If everything goes well, okay, no problem. Then go to the tools menu and select your tool. Oh no. It will upload the code and you will see the LED is blinking. Okay. So what you need to do now, in the same thing, first thing you do to write this program, turn on and turn off the LED. And after that, if you have enough time, then you go for LED blink. Any question?